Okay, we're looking at matrix multiplicative identity and the multiplicative inverse. So first I need to define a few things, what a square matrix is. So a square matrix has the same number of rows and columns. So an example might be A, B, C, D. That's a 2 by 2 square matrix. Okay, so the number of rows equals the number of columns. Pretty easy. Okay, so multiplicative identity, so that's denoted by a capital I. And you can see there's an I sub 2 and I sub 3. I sub 2 is a 2 by 2 identity matrix, and I sub 3 is a 3 by 3, and you can have larger ones as long as it's a square matrix. Now, not only is it a square matrix, but I2 has ones on its leading diagonal and zeros everywhere else. And in fact, any identity matrix has that pattern. That's what makes it an identity matrix. So 3 by 3 would be 1 on the leading diagonal, zeros everywhere else. And you could imagine what it would be like for larger ones. So the identity matrix, which is the result of multiplicative identity, is I guess analogous to the number 1 in real numbers. However, we wouldn't get the effect if we had ones in every spot. We have to have zeros in every place, except for along the leading diagonal you can see that the elements are all ones. So that brings us on to, if A is a square matrix and matrix B can be found such that A times B gives an identity matrix, and that also equals B times A. We said A is invertible and B is the inverse of A. So A is said to be invertible. That means the inverse can be found, and B is the inverse, the multiplicative inverse of A. And notice that it has to work both ways around. B times A will give I, and A times B will give I. So it's only in specific cases, because we've noticed that in general, A times B does not equal B times A in general, but not always, usually. Okay, so that is a particular case. So if A is invertible, not all matrices are, if you can find the inverse, A times its inverse will give you I, which is the same as the inverse matrix times A. Alright, so really these two statements are the same, just with different symbology.